So in order to create 28 subnet, we need to use a formula, that is, so this is Nirbhay and welcome back to part 3 of subnetting. So in this video, we will see subnetting according to network. Okay. So in the second part, we have already seen subnetting according to host. Okay. So now let's see what are the differences between subnetting according to host and according to networks, so that you can understand this video in much better way. So in subnetting according to host, we do subnetting as per the host requirement. As you can see, there are 50 host requirement is there. Okay. Where that number of subnet can be of any, like 1, 2, or it can be any that are possible. Okay. As we have also seen in part 2 of the subnetting, where we have already taken subnetting according to host in our previous video also. Like you on the screen, you can see there are different interfaces and routers. Okay. And on each interfaces there are different host requirement like 30, 50, 22. Okay. So basically here we are doing subnetting according to the host. Okay. Whereas in subnetting according to network, it means like there will be requirement of specific subnet, like how much subnet you want, let's say 5 subnet or 6 subnet. Okay. So it means there is also priority given to number of network also. Okay. And as well as to how many hosts that are being required. So it can be consistent like 60 hosts for each subnet, or it can vary. So in short, I can say when we do subnetting by seeing their host requirement like 50 host, okay, so that is termed as subnetting according to host. And when we do subnetting by taking care of how many subnets are required, then that is termed as subnetting according to network. So now let's understand subnetting according to network by taking an example. Okay, so our question is, consider the IP address 165.120.60.0 where we need 28 subnet in such a way that each subnet may host up to at least 60 hosts. Okay. So in short, if we try to understand this question, okay, so the given IP is 165.120.60.0. Okay. And by using this IP, we have to create 28 subnet in such a way that each subnet should consist of at least 60 hosts. Okay. So now let's see how we can do this thing. Okay. So first of all, what we need to do in first step, we need to write the given IP address as it is. So what is it? Is 165.120.60.0. Okay. Now we have to identify the bit that are given to network and the bit that are given to host. Okay. So in class B, you can see the first 2 octets are given to network and last 3rd and 4th octet are given to host. Okay. So means it was for network and host. Okay. So now we have to make the bits that are given to host as 0. Okay. And write the bit that are given to network as it is. Okay. So it will be 165.120.0.0. Okay. And in the second step, we have to convert the bit that are given to host in their binary. Okay. And we have to write the bit that are given to network as it is. Okay. So it will be 165.120. Now if we convert 0 into binary, so it will be 8 times 0. Okay. 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now as per our question, as you can see, we need to create 28 subnet. Okay. So in order to create 28 subnet, we need to use a formula, that is 2 raised to n. And we need to satisfy the condition. It should be 2 raised to n. It should be greater than or equal to 28. Okay. So we have to take value in n such that it should be greater than or equal to 28. Okay. So in the table, that is from 2 raised to 0 till 2 raised to 7 of 8 bits. Okay. So in this, if we take 2 raised to 4 means n as 4, so it will give us 16. Okay. So 16 is less than 28, so it will not satisfy the condition. Okay. So if we take 2 raised to 5 means n value as 5, so it is 32. Okay. So 32 is greater than or equal to 28. Okay. So it satisfies the condition. Okay. So 2 raised to 5, which will give us 32, which is greater than or equal to 28. Okay. So this satisfies the condition and the value of n become 5. Okay. So in the fourth part, what we need to do, we need to again write this, the bit that are given to network as it is and the bit that are given to host in binary. Okay. So we will write it 165.120. Again 8 times 0 dot Now as our n value was 5, so we need to take the 5 bits from host from left to right, okay, and write other bits as it is, okay. So I will be writing the bits that are given to network as it is, okay, and again 120, and this is our first host bits, okay. So we need to take 5 bits from left to right, okay. So I will be writing 5 times 1, 1 2 3 4 5, okay. So as a octet consists of 8 bits, okay, so remaining are 3, so I will be writing 3 times 0, and this whole I can write as it is 5 6, okay. Now we have to find its value, okay, that is it will be 2 raised to 7, okay. So it will be 128 plus 64 plus 32 plus 16 plus 8, so because it is starting 5 bits, okay. So you can see it will be 2 raised to 7, 2 raised to 6, 2 raised to 5, 2 raised to 4, 2 raised to 3, okay, till 2 raised to 3 it will be, and if we sum up all the value, so it will give us 248, okay. So we need to write this value in decimal now, okay. So it will be 165.120 dot, if we sum up all this, what we will get? 248.0. so this is what, this is the last subnet id, okay. Now we need to find the subnet mask, okay. So what basically that subnet mask was, it represent how many bits are given to network and how many bits are given to host, okay. So by default, what is the subnet mask for class B? So it is 255.255.0.0, because here also you can see first 2 octets are given to network and rest 2 octets are given to host. So as all ones represent in decimal as 255 and all 0 in decimal represent as 0, so it will be 255.255.0.0, okay. But in our case subnetting is being done, okay, where it is being done in the third octet itself, as network has borrowed some bit from host in third octet, okay. So what will be its subnet mask? So it will be, as first 2 octets are constant, okay, so it will be 255.255. now in third octet some bits are given to network, okay. So how many bits are given to? 5 bits, and in decimal what it represent? 248, so it will be 248.0. so this is our subnet mask. Now what will be our first subnet id? Okay, so in order to find the first subnet id, what we need to do? We need to write the bit that are given to network as it is and make the host part to 0, okay. So here you can see we have already done that, okay. So means 165.120 that are given to network by default in class B, okay, and rest 2 that are given to host, we are making them as 0.0. But what will be its CIDR range? Okay, so by default the CIDR range for class B is /16, okay, but here some bits are given to network in third octet, okay. So how many bits are given to network? It's 5 bits are given to network, okay. So 16 plus 5, which will give us 21, so means 21 will be its CIDR range. Now what will be its second subnet id? So in order to find the second subnet id, we need to find the value of first network bit that are given from host to network, okay. So what is the first network bit that is given from host to network? Okay, so that we need to look from right to left, okay. So it is at 5th position from left to right, and from right to left it is at 4th position, okay. So 4th position means 1 2 3 4th, it is means 2 raised to 3, its value is 8, okay. So now what will be our second subnet id? So it will be, we need to write our bit that are given to network as it is, so 165.120, and in third also we have giving some bit to network, okay. So subnetting was done, and here only we need to provide that value. So what was that value? It is 8, okay. So our subnet will increase by 8, okay. So it will be 165.120.8.0 again 21, okay. Similarly third subnet id will be, again it will be increment by 8, so it will be 165.120.16.0/21, again fourth will be 165.120.24.0/21. So now let's say what will be the broadcast IP for this third subnet, okay. So it will be just an IP before its fourth subnet. So what was our fourth subnet? It is 165.120.24.0. Okay, so what will be our IP before the fourth? Okay, so it will be 165.120.23.255. Okay, so why I have written it like this? If you have watched my previous video, then you can easily understand this. Okay, so it is because after 255 this will become 24 and here it will become 0. Okay, so this was our broadcast IP, okay, for the third subnet. So what will be our last subnet? So it will be this only, that is 165.120.248.0. so by increasing this third octet value by 888, we will end up with the last subnet ID, that is 248.0. okay, so in between we will find 32 different subnets. Okay, so this satisfies our first condition. Okay, but now the second condition was we need at least 60 hosts. Okay, so to find the host there is another formula. Okay, so that is 2 raised to n minus 2, which should be greater than or equal to what? 60. We require 60 hosts. Okay, so we need to satisfy this condition by separating 2. It should be greater than or equal to 60. Okay, so but in our case, as already subnetting is being performed and some bits are given to network. Okay, so total how many bits are given to network? So it is 21. Okay, and in an IP address, how many total bits are there? So it is 32. So 32 minus 21 that are given to network, then how many bit remains? So it is 11. Okay, so 11 is now for host. Okay, so if we do 2 raised to 11, so it will give us 2048 total host. So means in a subnet total 204 hosts are possible. Okay, so if we subtract 2 also from here, like 2048 minus 2, so it will give us 2046. Okay, so this satisfy our condition, means 2 raised to n 2048 minus 2, it will is equals to 2046, which is greater than or equal to 60. So this satisfy our this condition also. So by this way we have done subnetting according to network. Okay, so now let's take one example to understand subnetting according to network in much better way. Okay, so I have taken a random IP, that is 165.120.17.0/21. Okay, and we need to find this value, that is subnet mask, and we need to find whether it is a valid subnet ID or not. So if it is a valid subnet ID, so it will be that only. If it is not, then what was the actual subnet ID? Okay, the number of usable host and usable host range, and what was its broadcast IP. Okay, so if you carefully see this IP, that is 165.120.17.0/21, so you can see from our previous example, so that IP falls within the third subnet. Okay, so our third subnet was starting from 16.0/21 and it ends up here 165.120.23.255/21. okay, so that IP was in between this range. So this thing we know and you know. Okay, so but what you directly get some other IP and you don't know about that. Okay, so but still how you can find this values? Okay, so firstly what we will do as our first step, we will write the given IP as it is. So it is 165.120.17.0. okay, and as this IP is from class B. Okay, so by default first two octets are given to network and last two octets are given to host. Okay, so we have to write the bit that are given to network as it is and make the values that are given to host as 0. Okay, so I will be writing 165.120 and this thing I will be making as 0. Okay, now we need to write that in binary. Okay, so I will be writing the bits that are given to network as it is. So it will be 165.120 and rest thing I will be writing in binary. Okay, so that will be 8 times 0. Okay, again 8 times 0, 5, 6, 7, 8. Okay, so now by default how many bits are given to network in class B? So it is 16 only, but here we are given 21 bits. Okay, so what we need to do, we need to write the first 16 bits value as it is. So it will be 165.120. okay, now how many extra bits are given to network? That is 5 extra bits. Okay, that is 21 minus 16, it will give us 5. So we have to give the 5 bits to network from left to right. Okay, so we have to give 5 bits, 1 2 3 4 5, and pending 3 we have to write as 0, means total from 8 we have given 5 to network, and pending 3 we have to write and give to host. Okay, and rest thing again all zeros, 5 6 7 8. Okay, now we have to write its decimal value. So what it will be? It will be 165.120, and if we calculate its value, so it will be 128 plus 64 plus 32 plus 16 plus 8, so it will give us 248. Okay, so it will be 248, and again the decimal for 0 will be 0 only. So this will be our last subnet ID. Okay, basically it was our last subnet ID. And to find the subnet mask, basically what it denote, the number of bits that are given to network and the number of bits that are given to host. Okay, so our subnet mask will be, as we have already given first 2 octets to network. Okay, so means all ones in represent in decimal as 255.255. okay, and from third octet also we have given some bit to network. So in decimal it was 248, and for fourth octet it is as it is, means all are 0. So in decimal it will be 0 only. So this will be our subnet mask. So let I quickly write it here. So it will be 255.255.248.0. okay, now we have to find whether it is a valid subnet ID or not. Okay, so basically we will find its subnet ID, and by verifying with it, if it is same, so we can say it's a valid subnet ID. If it is not same, so we can say it is not a valid subnet ID. Okay, so we will find its subnet ID. So to find subnet ID, firstly what we will do, we will write the bit that are given to network as it is. Okay, so in class B the first 2 octets bits are given to network. Okay, so what those are? So it will be 165.120. okay, so we will write the first 2 octet bit as it is, 165.120. okay, and third octet some bits are given to host. Okay, so to find subnet ID, what we need to do, we need to perform the AND operation between the third octet value of subnet mask and between the third octet value of an IP address. So it can be 248 and 17. Okay, so for this to perform the AND operation, simply open your calculator and click on the 3 lines and select programmer and type 17 drop down and select and write 248 and equals to, so this give us 16. Okay, so we have to now write as 16, and anything we do AND operation with 0, it will result in 0 only. So here also 0 is there and here also 0 is there, so it will give us 0 only. And what will be the CIDR range? It will be /21 only, because 5 more extra bits that we have given to network. Okay, so this will be our subnet ID. So whether this is same with this, you can see here 17 is there and here 16 is there. So this was his actual subnet ID. So we can say whether it is a valid subnet ID. So we can say no. Okay, so what was his actual subnet ID? It is 165.120.16.0/21. Okay, so now we have to find the number of usable hosts. Okay, so from this we have seen like 21 bits were given to network. Okay, and total 32 bits were possible in an IP. Okay, so 32 minus 21, it will give us 11. Okay, so to find the number of usable hosts, we basically use 2 raised to n minus 2. Okay, so if we put the value of 11 in n, so it will be 2 raised to 11 minus 2, so it will be 2048 minus 2, it will be 2046 actual usable hosts. Okay, so what was the value of actual usable host? So it will be 2046. Okay, now we need to identify the usable host range, from where it will go till where. Okay, so to find it, we need to find the value of first network bit that is given from host to network. So what was that first network bit? So you can see this is the one in the second step. You can see the one that is given from host to network. This was the first value. Okay, so from the left to right, it is the fifth, it is at fifth position, and from right to left it is as fourth position. Okay, so if you take from right to left, 2 raised to 0, 1 2 3 4. Okay, so it is basically 2 raised to 3 and its value was 8. Okay, so our subnet will be increasing by 8. Okay, so what will be the next subnet? Okay, so as we have done subnetting in third octet, so our next bit will be increasing in third octet only. Okay, so what will be our next subnet? So it will be 165.120.24.0/21. so it will be the next subnet after this. Okay, so what will be our usable host range? So as we found this, the next subnet, so an IP before this subnet will be our broadcast IP. Okay, so that will be 165.120.23.255.0/21. Okay, so we have already find our broadcast IP. So it was usable host range. Okay, and 8 we have found broadcast IP. So it was 165.120.23.255. Okay, so this was our broadcast IP. Okay, so what will be the actual usable host? So actual usable host range will be the IP excluding its subnet ID and the broadcast IP. So what was its subnet ID? So it was 165.120.16.0/21. Okay, so the next IP will be its usable host range. Okay, so what it will be? It will be 165.120.16. After 0, what it will become? It will become 1. Okay, so from here till where it will go? By excluding this broadcast IP, means just an IP before this broadcast IP. So it will be 165.120.23, and before 255 what it will come? It will be 254. So this will be its actual usable host range. So let I quickly write it. It will be 165.20.16.1 till 165.120.23.254. Okay, and broadcast IP we have already find. So it was 165.120.23.255. So we have successfully solved this question. Okay, but there is one other thing that comes into picture. Like, so in this example you can see for every subnet the possible usable host was 2046. Okay, but suppose if someone wants, in the first subnet ID they want to allocate 1000 host only, and for second let's say 1500, and third they want 2000. Okay, so how we can do this? Okay, so for this another advanced concept comes into picture, that is VLSM. So for this, if you want me to make a video on this, so please comment in the comment section. Okay, so till now if you think I have explained you subnetting in a better way, so you can simply like, subscribe and share, and if you have any doubts you can simply comment in the comment section. Till now,